Good morning, children. How are you all? Enjoying life? I hope you are enjoying chemistry classes too. Now, today is your fifth and last session of the chapter Atomic Structure. We start our class with the topic ions. When an atom loses or gains electrons, it becomes a charged particle or ions. An atom that loses one or more electrons to form a positive ion is called a cation. Example, sodium and magnesium ions. Atoms having 1, 2 or 3 electrons in their valence shell tend to lose electrons and form cations. These are mostly metal atoms. The first example that we take today is sodium atom. Electronic configuration 281. So only one valence electron in M shell. It loses this one electron from the M shell to become stable with 8 electrons in the L shell. And it forms sodium cation, valency +1. The next example is calcium atom with electronic configuration 2882. So 2 valence electrons in N shell. It loses these 2 electrons from the last orbit to form calcium cation Ca2+. An atom that gains one or more electrons to form a negative ion is called anion. Examples are chloride and oxide ions. Atoms having 5, 6 or 7 electrons in the valence shell tend to gain or accept electrons and form anions. These are mostly non-metals. One such example is oxygen atom, atomic number 8, electronic configuration 2,6. That is, it is short of 2 electrons. So, in order to become stable, it gains 2 electrons from some other atom. Therefore, valency is -2. Chlorine atom has electronic configuration 287. So, in the last shell, it requires one more electron to become stable. It accepts one electron to form chloride ion and anion, valency -1. So, now we can say that an ion is a charged particle because it contains unequal number of electrons and protons. An ion that contains only one single atom with a charge is called a monoatomic ion. Here's a list of monoatomic cations and anions. In each case, a single atom is carrying a charge. The charges can be +1, +2, +3 or -1, -2, -3. Any of these. But if an ion consists of a group of atoms with an overall charge, then it is called a polyatomic or compound ion. In the list, you can see NH4+, ammonium ion, SO4 2-, sulfate ion. Likewise, you have nitrite ion, nitrate ion, hydroxide ion, carbonate ion. Note here that all compound ions have negative charges except for ammonium ion, which is positively charged. Interesting, isn't it? Monoatomic and polyatomic ions are also known as radicals. Cations and anions join together to form compounds. All compounds are neutral and net charge is 0. So here you can see sodium ion and chloride ion join together to form sodium chloride compound. Magnesium ion and oxide ion form magnesium oxide. Copper ion and sulfate ion form copper sulfate. Ammonium ion and nitrate ion form ammonium nitrate. In chemistry, compounds are represented by chemical formula. A chemical formula of a compound is the symbolic representation of its composition. It tells the number of atoms of various elements present in one molecule of a compound. Also, in a chemical formula, the ratio of different elements present in that compound is represented by subscript. Here are the rules for writing down the chemical formula. We first write down the symbol of that element or ion that forms the compound. Write down the valency of each element or the charge of each ion as superscript on the right hand corner of the symbol. Interchange the valencies or charges of the combining atoms or ions and write them as subscript. Note, while doing so, exclude the plus and minus signs. If the valencies or charges are divisible by a common factor, then divide and simplify the formula. In cases of the formulae of compounds containing polyatomic ions, the same rules are applied, except that the formula of polyatomic ions is written within bracket before writing the subscript. Note, while writing down the formula of a compound, always write the cation first followed by the anion. The rules that have been explained to you for writing down the chemical formula is the crisscross method of writing formulas. We will use this method and practice a few examples. The first example we take is sodium chloride. We write down the symbol of the ions Na plus and Cl minus. Interchange the charges and bring it down as the subscript Na1 Cl1. Since both the subscript is 1 1, so we can simply write NaCl. So this is the formula of compound sodium chloride. The next example is calcium oxide. Symbol of calcium ion is Ca2 plus. Charge is 2 plus. Oxide ion is O2 minus. We interchange the charges. So it becomes Ca2 and O2. Since both are same, we can reduce it by common factor, write down CaO. So this is the formula calcium oxide. Example is water. The formula for water. Elements present in water is hydrogen and oxygen. We write on the valency of hydrogen as 1, oxygen as 2. Interchange the valencies and write down as subscript H2O1. Now 1 we can skip writing, just write down H2O. The next example is magnesium chloride. Ions present is magnesium ion Mg2 plus and chloride ion is Cl1 minus, or you can write down as minus 1. It is one and the same. You exchange the charges, the valencies, write down Mg1 Cl2. Now 1 you can skip writing and just simply write MgCl2. Here without 1 written, even though it is understood that magnesium atom is only one magnesium atom is present in magnesium chloride molecule. The next example we take copper sulfate. Copper is Cu2 plus and sulfate SO4 2 minus. Note, this is a polyatomic ion. Okay? Now, so again exchange the valencies and see carefully how I am writing. Cu, this 2 will come over here. Okay? And SO4 radical we write. This we write in bracket and this 2, that is plus 2, it comes over here. Note, while we change the valency to writing a subscript, we do not write down the plus and the minus sign. Now here this SO4 is a compound ion. So when reducing the formula, we just take into consideration the 2 that is outside the bracket, not this 4. We reduce it as 2 ones are 2 and 2 ones are 2. So we write CuSO4. We do not do anything with this 4. This 4 remains as such. Okay. The next example is sodium nitrate. Na, sodium Na plus 1 and nitrate is NO3 minus 1. Interchange. Okay. And you will be writing Na1, NO3, 1. So 1 you can skip writing and simply write NaNO3. Okay. Next example is potassium oxide. Symbol for potassium is K. Charge of potassium ion is plus 1. Oxide minus 2. Exchange the valencies. So you will write down K2O1 or K2O. Okay. The last one for today is ammonium nitrate. The ions present is ammonium ion NH4 plus, the only positive polyatomic ion. The negative ion is NO3 minus 1. Okay. This is polyatomic ion with positive charge. This is polyatomic ion with negative charge. We exchange the valencies. So it is NH4 1 and NO3 1. As usual, we skip writing 1 1 and we simply write NH4 NO3. NH4 NO3. Okay. In certain compounds, valencies of elements like hydrogen, carbon, silicon is not given the plus or minus sign. The reason is that they exist with positive as well as negative charges depending on the type of compound formed. So, we write only the valency number. More of it in details you will be studying in higher classes. The different elements that we have been studying are arranged in a chart called the periodic table. It was given by Dmitry Mendeleev. The periodic table of elements is a tabular display of the chemical elements which are arranged by atomic number, electron configuration and recurring chemical properties. The periodic table has horizontal rows called periods and vertical columns called groups. The elements in each group have same number of electrons in the outermost shell. So same valency for hydrogen, sodium and potassium. These valence electrons participate in a chemical reaction and bond formation with other elements. Therefore, elements in the same group have similar properties. Now, coming to the horizontal rows called periods, all the elements in a period have same number of orbits. For example, every element in the top row, that is the first period, has one orbit for its electrons. All the elements in the second period have two orbits for their electrons. That's all for now from the chapter Atomic Structure. Now, this is your assignment. Carefully watch the video, children. Understand each and every concept thoroughly and then try to do the assignment. All the best.